Okay, so welcome to another session. So we're going to be looking at lesson 3, continuation of where we stopped in our previous video. So again, this class is CompTIA Core 1, exam 2201101. So so far we've looked at lesson 1 and lesson 2. So where we look at how to build the system, the hardware, the motherboards, how to install devices, assemble the devices, your hard drive, your memory, your processor. So we look at all these ones in lesson 1 and lesson 2. So having built a system, the next thing we're going to look at is how do you troubleshoot those hardware. So we're going to look at troubleshooting hardware. How do we troubleshoot hardware? So our objective for this class, this lesson, is going to be applying troubleshooting methodology, computer BIOS and UEFI, troubleshoot power and disk issues, troubleshoot systems and display issues. Okay, so the first thing we're going to look at is applying troubleshooting methodology. This is 3A, applying troubleshooting methodology. So this is typically when your hardware is failing, when the system is not powering up. Maybe you are hearing some kind of noise from the system, no display, you're hearing funny sounds. So what do? Or the system is not coming up, what will you do? So CompTIA itself has a methodology, has a process that is already defined, which is a framework that is already proven and designed for troubleshooting issues. So we're going to look at this framework, this methodology, and see how we can apply them in real life scenario. Okay, the first thing we're going to look at now is the steps involved in troubleshooting methods. So we have, like I said, this is a CompTIA troubleshooting model. So we have about 6 models, six steps. So we have 6 steps in this methodology. So we have 6 steps. So we need to understand the first thing. We need to see how do we solve problem. What are the causes? What is causing this problem? For instance, if the computer is not coming up, so you want to know, you want to solve it. Then in solving it, you want to ask a question: why is it not coming up? That is the causes. So what are the negative symptoms? So what symptoms is this giving, and what are the consequences? All right. So in other words, there are also other corporate policies and procedures and impacts. Some companies, they have their own procedures. They have their corporate policies that you must adhere to when you need to troubleshoot systems. Right? So this model is actually for CompTIA. So this is a CompTIA troubleshooting model. So you might be working in an organization, you might start working in a company, and they might have their own procedures, right? Which are policies, their corporate policies, how to troubleshoot system. So you might need to adhere to that. But for CompTIA security, for CompTIA troubleshooting, for CompTIA, the troubleshooting model is in 6 stages. So like I said, this is not holistic. This is just solely for CompTIA. So you can decide to adopt it. You can try to adopt this process, or you can just adopt whatever practice your company, where you work, they're adopting. Now, when you start working with computer systems, the practical aspect of it, you can also develop your own troubleshooting methodologies too. For me, I have my own troubleshooting methodologies. So if a system is having issues, there are a series of steps I have to take before I identify the problem. Now, without much ado, let's look at the 6 stages, or rather the processes in CompTIA troubleshooting model. The first one is say identify the problem. Then second one, establish a theory, test the theory, establish an action plan, verify full system functionality, and document findings. Okay, so when we say identify the problem, what do we do? When we say identify the problem, what do we do? I'm not seeing myself here in this video. Okay, so when we say identify the problem, what do we do? I'm just trying to sort out some display issues with trying to supply some display issues, right? Okay, so sorry, I'm trying to sort out some display issues here. Okay, so let's continue. Okay, so just sorry about that. Just trying to cover some. My display is not coming out very well, so I'm trying to sort it out. So let's continue. So we want to talk about identify the problem. So the first thing we need to know about that is you want to get as much information from users, right? If a user calls you that his computer is not coming up, you have to ask relevant questions. About it, what's happened, what were they doing, you shut the system down. If it's a display problem, like you have to ask question, was he up earlier before he left the office? You ask the necessary question. That's also gather information from users, identify the changes, you inquire regarding environment or infrastructure changes, like I said. Then if you've done those things, now it's very important before you start working on the computer system, you have to perform backup. So before you make any change on the system, the first thing to do is to carry a backup. Don't work on the computer without backup. Very important, right? So you must do backup, right? So backup means that the files, the data of the user, you secure them. So we're not going to explain much about that. But in a situation whereby the system is not coming up, and you need to start working on the system, your first goal is to ensure the system comes up. That's the first goal, right? So before you start going further to work on the hard drive, you must ensure that the data inside the hard drive are backup. That's if the issue has to do with the backup. If the issue has to do with hard drive anyway. So let's continue. Okay. So you perform backup, then stage 2, you establish a theory. So you've done you identify the problem, you ask the relevant questions, then you need to ask possible theories, like from possible causes to probable causes. Like you ask yourself, these are likely causes of this problem. You look at the probability of what might have caused this system for not coming up. Then, of course, you conduct internal, external research. So that means you look at the physical aspect of the system, internal documentation and support resources, external vendor and volume resources. So there are a lot of times whereby it might be a hardware problem. So before you start going extensively, you must look at the documentation about the hardware. So look at the internal documentation, your company policies, look at their procedures. Then when you notice that the hardware, everything are intact, everything is fine, but still the thing is not working, the hardware is not working, what do? You look at the external vendor. So external vendor are likely people that sell this product. Look at them, go to forums and research if I get information about the hardware. Then questions, the obvious, which are attending to detail. Step 2, what should happen? So what means is that when you say you ask the obvious question, so it's all about your attention, details. So you look at the attention detail, then of course you want to look at the step 2, what should have happened. So most likely, if for instance now we discover that the system comes up and after a while it restarts by itself, goes off, it comes up and restarts. So you might want to walk through all the steps. What should have happened that is making the system to restart, start and restart, start. So you want to look at what are the possible things that would have happened that would make this system to be restarting. Right? Then you compartmentize the issues. So you ensure that if you look at all the various issues, you ensure that you itemize them and make them just one. You compact them into one. Then establish a theory. So at this place, it's just about what are the obvious things, what would have caused this thing, right? So what are obvious things, like you're looking at what's caused it? Okay, this system must have happened. This system must have happened. Maybe it's a restart. It must have what have happened. Probably maybe it's a virus problem, or maybe it's a hardware problem, a faulty hardware. So a faulty hardware can make a system to be restarting. Right? Then you look at other alternative issues too that must have caused around it. If it's a restart problem, what must have caused it? Right? Maybe it could be a memory. A faulty memory too can make a system to restart. It's not, it could be a memory, it could be a processor. So you look at other alternatives so that you don't narrow your research, your courses to just one. Then you take system, to base. So take system to base means that you might want to take the system from where it is to your workshop where you can work on the system. Because in most cases, it's not advisable to work on the system with the customer. It depends on the customer. Sometimes I will not like to take that system away. Some user. So if you need to work on the system there, then you work on the system where the customer is or where the user is, or you take it back to the base. Escalate. So escalation means you've done all you need to do, instead it's not still working up, it's not still working, you've done every necessary thing, you've talked to your peers, your colleague, they've tried to work on it too, they couldn't do anything, then at this time you have to escalate. So that's why we have to talk to support people. You call support, so the product, who are the vendor, you call them, you speak with them, you'll be able to seek support from them. So all these are stages, right? The next thing is to implement an action plan, right? So if all those processes you've gone through the necessary process, then of course you want to start repairing the system, then you have to look at, what you need to do, what are the cost implications to repair the system. You understand? So you look at the cost to repair the system, what are the implications, what are the risks involved. Like I told you, before you carry out maintenance work, ensure the system are backup. Very important, right? Then after that, you look at an action plan, establish an action plan. So what are you going to do? What are you going to do? If you're going to work, so what are going to be the impact? So the action plan, consider the impact. Corporate policies too, procedures and impact. Now, some companies have procedures, like I told you. Before you work on a system, there must be procedures. You don't just work on a computer like that. You must follow procedures before you work on some computers, right? So you follow procedures. Every company has policies. They have their policies, their corporate policies about computers and everything. So any procedure to repair systems, you must take permission from your line manager, right? If it's a company, you take permission. You document the courses, you write it down. Put the date, what are the symptoms, the system is giving, you write it down, and your action plan, you're going to document them, right? You follow the procedures on how to troubleshoot. Some companies have their procedure. Some companies, they have already procedures. If a system is down, what you need to do, they're there. You have to follow them, right? They implement the solution. So after everything, you're going to implement solution. So solution means that you must carry the necessary people involved. If a system that, it depends on the system, right? If the computer that does a lot of, that provides services, like for instance, accounting system. An accounting system, is very important because, the company is used for accounting recording purposes and for money, very important. So if you're going to work on an accounting system, you have to inform the necessary stakeholder. That's what change management comes in. You must inform people, tell them that this is what we are doing on this system. We're going to work on this system. Between so time, this system will be out of service. We are doing maintenance on it. And you schedule the time, let them know this is the time we're going to work on, and this is the time the system will come up. All right? Then, of course, there's also refer to vendor instructions. So there's some systems, that you must, before you work on them, you must follow the instructions by the vendor. All these are very important. So, system is working now. You verify the system for insurance. You perform a test. So you verify the system is working very well now. You test it. Then, of course, obtain user acceptance. So the user have to verify too that the system is working. So if the problem is, that was there, and you see that you resolve the problem, you ensure that the user itself identifies that, right? Then, of course, implement preventive measures. So at this point in time now, you want to look at, okay, what would have caused this problem? Then you want to say that it doesn't happen again, right? If the problem was as a result of probably it's the power surge was affected the system that is making to restart. So what do? You ensure that the system has UPS. So that next time, UPS means uninterrupted power supply. So ensure that the system is in place by whatever happens, system not goes off. So always be on. So you put the power supply there. That's another way of making preventive measure. Document everything, what are your findings, your action, your outcome. You document and you track the systems. So these are the stages, right? Okay. So 3B, configure BIOS and UEFI. Configure BIOS and UEFI. So what are BIOS? And we call it basic input and output system. Then UEFI means, okay, here we go now. So BIOS and Wi-Fi, right? So I think let me stop. Okay, let's continue. So system firmware, BIOS and UEFI. So a system firmware are usually software that comes with the manufacturer product. That software comes with hardware. For instance, your phone you use now, it has a firmware. Instead of start, there is software that loads on it. So it's all about the software there is all about the products, what is being made inside. So those products, the hardware, the component inside, they are being regulated by the software. So that software there is firmware. So that's firmware, the software owned by the manufacturer of the product. They build that product to manage all those hardwares involved. Right? So that is the firmware. Now, for most computers, the firmware is called BIOS, which is called Basic Input and Output Systems. So when you're on the system, the first thing to do is to go to BIOS. So the BIOS there, it contains everything, all the hardware you install, the functionality of the computer system, everything is in the BIOS. So in the BIOS, you can look at the date of the system, look at the hard drive, every hardware that is installed. You can set how the system is going to perform, USB, everything. From there you can disable some function from working. So the BIOS is very important, right? And now aside the BIOS, we also have another firmware called Unified Extensible Firmware Interface. So back in the days, most systems firmware are usually BIOS. Now, but we know the computer system is always progressive, it's always evolving. So based on that, so the new modified system firmware now is Unified Extended Firmware Interface. So now most of the firmware you see now, they are UEFI, which are Unified Extended Firmware Interface. Right? So they are similar to the BIOS. The difference is just what one is the modified one. So this one is the old one. This is the modified one of BIOS. So we have the accessible. How do you access the BIOS? Very important. How do you access them? So like I said, the BIOS and the UEFI, they are the firmware, that is software of the hardware. All the system, when you build a system, the hard drive, everything, the memory, the motherboard, the processor, the clock speed, everything about the system, your mouse, your keyboard, everything, the system date and time, they are all they are all inside the BIOS. You have to go and set them up inside the BIOS or the UEFI. You must set it up there. Right? Very important. Then if you set it up there, if you set it up there, then from there the system is going to control how the system function. A wrong configured hardware will not function when you get to Windows environment. So it's very important that you ensure that every hardware that is set up, on your system, it functions very well in your firmware, on your BIOS and your UEFI. So how do you access the BIOS? Very important. To access the BIOS system, there are various ways, depends on the manufacturer, right? Now, some manufacturer, before you can access the BIOS setup, you must press for the combination of keys. Some of them just simply pressing F2, some is F10, some is delete key. So as system starts, before the system boots, as you just on the computer system, before it boots up, just start hitting the key from your keyboard. So some systems will say F2, some systems will say press delete key, some F10, some F11, some F12. So as you on the system, want to go to the BIOS, you press on your keyboard F2, the key on your keyboard, if it's delete key. So in most cases, when you're on the system will show you, say press this. For instance, HP system will tell you is delete key, depends on the system anyway, and depends on the chipset they use. Some use F10. As on, if you just press F10 to go to setup, BIOS setup. Some tell you F2. Some tell you delete key, which is Dell. So whichever product you use is going to tell you. Right? Okay. So now, very important. So how do we? There's some cases whereby some systems are very fast. The moment you on it, like take a look at this place now. Look at this place now. See, F2 system setup. See F11 BIOS boot F10 system services, F12 PXS boot. So F2 here, it said system setup. So you can use F2 to go to BIOS setup here. See it now. It tells you. See F2. So this is a Dell. This is Dell. It's telling you already the key that you're going to use to go to setup. Now, there are some systems that they are very fast. Before you on it, before you pronounce your name, before you call your name, say Samuel, for instance, it's already passed. You will not see it's going to Windows environment. You will not see the key to press. So in most cases, what you do, if you want to do the key to go to BIOS setup, go to Google. Once you go to Google, just type in on the system and said what key for BIOS setup. It will tell you the key. Then you on the system. You just press the key continuously. Then you take the BIOS. So now this is a typical example of the BIOS setup, right? This is a typical example of BIOS setup, right? Typical example of BIOS setup. Now in the BIOS setup, you can have something like this. You can have something like in the BIOS setup, right? Now in something like this, this place is a menu. This is a menu in BIOS setup whereby we can be able to determine how our system boot and device option. So how do you determine the boot priority? Booting means when system starts, where is it going to start from? So you want it to start from your hard drive, you want to start from your flash drive, you want to start from your USB, you want to start from. You just have to decide where is it starting from. Now in most cases, right, when you are installing a system for the first time, maybe you want to install from a USB, you want to set up the system up. So at that time, you cannot start the system from your hard drive because the system is not ready. Right? So you make a system now and you on it and you want to install OS. So what will you do? So you have to go to the BIOS setup and go to say, okay, where am I going to install the OS from? if you have a USB, because we have some USB that have bootable, that we call them bootable. So bootable means that it can start from the USB. So you've already downloaded your Windows setup. So your Windows setup is the file that contains the installation. You've already downloaded that setup inside your USB. So what will you do is to insert that USB to your computer system at the USB port, insert it, then go to BIOS setup. So when you go to BIOS setup, you will see all this, look at it, boot sequence. Go to boot sequence, then look for USB. See, you make sure that by hitting the keyboard, you should make your USB your first boot device. So your priority becomes the USB, right? Because that's where you want to load from. Make it your boot device. Then the second boot becomes your hard drive, because the hard drive is what you're installing to. The national system starts. It's now look for what your first boot option, which is what USB. Then you start installing from there. Just follow the instruction of how to install, installing from there. So these are how to set up system. So you install it. After installing it, take away your USB from the hard drive, from the system. Take it, unplug it. Then you can go back to BIOS and ensure that your first boot sequence is what hard drive, so that the system does not look for a USB when it's booting. So I can start from what hard drive, right? It's very important. Okay, so you can set for security reasons, you can set a password on your BIOS. For security reasons, why do you set BIOS? Why do you have to put the password on your system setup, so that you don't want people to go and be changing the settings there? Like we explained earlier, the firmware is very important, right? Somebody can go there and tamper with it and change configuration there, change some configuration where you don't want. So what you do is to ensure that everything is fine. So you go to BIOS and you work on it. You put everything there, ensure everything is in good order, right? So you put a password. When you put the password, then nobody can be able to come there and change your settings, all right? So a lot of people put that, but a lot of people also do not put that. They don't bother to put the password on BIOS settings. But for security reasons, it's always good to put a password on BIOS settings. So the something I want to tell you later, if it's here, I want to talk to you about it. It's called CMOS battery. So if it's not here, I will talk about it later, right? So let's go on. Let's see. Okay, so now we also have some other interesting topics here too. Encryption and cryptographic keys. So some of you might be new, in computer engineering, networking, security, cyber security. So you might be hearing about encryption and cryptographic keys. So encryption is all about changing the appearance of your text, of your file. You want to change it, you want to hide it, you want to look different. That's encryption, right? So you hide it to make it look different. You code it. So there are different ways of doing it. You encrypt the file. You can do it on the system. You encrypt it, and when you encrypt the file, the file must have a key. That key is what we use to decrypt it. So in most cases, when you encrypt the file, where is the file stored? So most times the encryption keys, when you encrypt the file, the keys to decrypt it, they are stored in the system. So the files are stored inside the computer system, which means when hacker get access to your system, they can see the key inside your document and they can steal it and use the word decrypt that file. So that's why we now have TPM, Trusted Platform Module. Trusted Platform Module, these ones are the hardwares, they are chips that are embedded on your computer system, on your motherboard. So what happens is that these chips, they store encryption keys. So instead of you to encrypt your file and store the key on your documents or your Windows environment where hackers can go, you now encrypt it and store it inside the chip or your motherboard, which is called Trusted Platform Module. So that one is very secure, right? So you can store password inside. You can store password there. You can store what call certificates. Now, certificate is high for you now. I'll know after I explain it, but it's a high level for you now. All right, we'll talk about it later. But